What is probability? Let me start off with a question. A fair coin, when tossed, will result in either the head showing up or the tail showing up. The tossing of the coin is called an experiment, and the odds of getting a head or a tail is called its probability. The result, whether it's head or tail, is called an event. A random experiment that has exactly two possible outcomes is known as the trial. Now, what is the probability that if a ball thrown up in the air does not come down? This can never happen because the ball thrown up definitely comes down due to gravity. Therefore, this is an event with zero probability. Zero probability is the one which can never happen. On the other side, what is the probability that I get a natural number when rolling a die? No matter however a die is rolled, you will definitely get a number between 1 and 6. Therefore, the probability of getting a natural number here is 1. Though the world is full of uncertainties, sometimes some things are predictable. In our day-to-day life, we come across different instances such as chances are high that the storms may occur. Most probably India may win the match. I doubt that the exam will be tough. It might rain today. In each of the above sentences, there is an element of uncertainty. That is, various predictions can be done in the above cases. This uncertainty can be measured in terms of probability in most of the cases. That is, for any event E, probability P of E can be defined as the number of trials in which the event has happened divided by the total number of trials. So, the probability of the event head showing up when a fair coin is tossed is also called the empirical probability P of E, which is equal to 1 divided by 2. Similarly, the probability of any event is between 0 and 1. Consider a class divided into groups of 2 or 3 students. Let a student in each group toss the coin 15 times. Let another student in each group record the observations of heads and tails and write the corresponding observations in a fraction. Number of times a head comes up divided by the total number of times the coin is tossed, and number of times a tail comes up divided by the total number of times the coin is tossed. Therefore, calculate the fractions for combined data of groups, and we call these fractions as cumulative fractions. Let's now tabulate the observations of groups and calculate the resulting fractions. What do you infer from the table? As the total number of tosses of the coin increases, the value of the fractions in the column 4 and in the column 5 comes closer to 0.5. Similarly, if we roll a dice 30 to 40 times, we note that as the number of throws of the dice increases, you will find that the value of the fraction comes closer to 1 divided by 6. Now, what if we toss two coins simultaneously 10 times and record the observations? Now, write down the values of the following fractions. Let A is equal to the number of times no head comes up divided by the total number of times the two coins are tossed. And let B is equal to the number of times one head comes up and divided by the total number of times the two coins are tossed. And let C is equal to the number of times two head comes up and divided by the total number of times the two coins are tossed. Now, increase the number of tosses and record the observations. As the number of tosses increase, value of A, B and C becomes closer 0.5 respectively. Each simultaneous toss of two coins is called a trial. Therefore, a trial is an action which results in one or several outcomes. Similarly, if our experiment was to roll a die for getting an even number, then the event would consist of 3 outcomes. namely 2, 4 and 6. Therefore, an event of an experiment is described as the collection of some outcomes of that particular experiment. Now, let us consider an example. A coin is tossed 1000 times with 455 heads and 545 tails. Let us compute the probability for each event. Number of trials is 1000 as the coin is tossed 1000 times. Let E and F be the events of getting head and tail respectively. Therefore, probability of event getting a head is calculated by number of heads divided by the total number of trials. That is 455 divided by 1000 giving you 0.455. And the probability of event getting a tail is given by number of tails divided by the total number of trials. That is 545 divided by 1000, which is equal to 0.545. Note that in this example, P of E plus P of F is equal to 1. And E and F are the only two possible outcomes of each of the trial. Now, let us consider another example where a record of the weather station shows that out of the past 250 consecutive days, its weather forecasts were correct 175 times. Now, what is the probability that on a given day it was correct? Also, what is the probability that it was not correct on a given day? Now, let us find the solution for that. The total number of days for which the record available is 250. Therefore, P, the probability that the forecast was correct on given day, is given by the number of days when the forecast is correct divided by the total number of days for which the record is available. That is 175 divided by 250 giving you 0.7. Then the number of days the forecast was not correct is given by 250 minus 175, which is equal to 75. So the probability that the forecast was not correct on the given day is given by the number of days when the forecast was not correct divided by the total number of days for which the record is available. That is 75 divided by 250, which gives us 0.3. Sum of probability of correct and probability of incorrect weather gives us 0.7 plus 0.3, which is equal to 1. Therefore, probability is extensively used in the field of weather forecasting, also in commerce, biological sciences, medical sciences, etc. Now, check the next question. Consider that 50 seeds were selected at random from each of 5 bags of seeds and were kept under standardized conditions favorable to germinate. After 20 days, the number of seeds which had germinated in each collection were counted and recorded as per the table. Now, what is the probability of germination of more than 40 seeds in a bag? From the data, we have total number of bags is equal to 5. Number of bags in which more than 40 seeds germinated out of 50 seeds is 3. That is 48, 42 and 41. Probability of germination of more than 40 seeds is equal to 3 divided by 5, which is equal to 0.6. Now, what is the probability of germination of 49 seeds in a bag? Number of bags in which 49 seeds germinated is equal to 0. Probability of germination of 49 seeds in a bag is equal to 0 divided by 5, which is equal to 0. So, what is the probability of germination of more than 35 seeds in a bag? Therefore, number of bags in which more than 35 seeds germinated is equal to 5 from the data. So, the required probability is 5 divided by 5, which is equal to 1. Therefore, the probability of an event can be any fraction from 0 to 1. Let's summarize. An event for an experiment is the collection of some outcomes of an experiment. The empirical probability P of E of an event E is given by probability of E is equal to number of trials in which E has happened divided by the total number of trials. The probability of an event lies between 0 and 1.